All right. Okay, so again, I want to do some more trig examples, okay? You know, trig is fun, okay? It is. I know if you go into pre-calculus, I know they go a lot more into it. So with trigonometry here, we're assuming, I know I didn't write it down, but if I gave you a question like this on the final, I would say assume theta is positive and less than 90 degrees. You know, in other words, it's acute. And we know also that cosecant of theta is equal to 9 over 8. So we have that. And what we're going to do is figure out all the other trig functions. That's what we're going to do. Okay, so now we have this. And again, what we want to do is make a right triangle, any right triangle we want, so that this holds. So that this here holds. Okay? Now, cosecant of theta, right? I mean, you could work with that directly. There is a definition of it in terms of opposite, adjacent, and all that. Now, I can never remember that definition, so I use the reciprocal identity here. Basically, we have cosecant of theta is 1 divided by sine of theta. 1 divided by sine of theta. Okay? That's what we have here. And so because of that, we have 1 over sine of theta is 9 over 8. So 1 over sine of theta is 9 over 8. That's what we have here. Okay. So because of that, because of this, that is, what you can do is you could cross multiply if you want. You know, I mean, I didn't do the calculation here. If you need help seeing it, don't be afraid to ask me. I can even email it to you if necessary. You know, I could like, what do you call it, like type it up or whatever. But basically here, we have sine of theta. You get from here basically by cross multiplying that sine of theta is 8 over 9. I said this to the other class also. I hope it makes sense. You can also, since you have 1 over sine of theta, you can actually just flip this to get sine of theta, but you have to flip this as well, and you get sine of theta is 8 over 9. I mean, you could just do that if you want, if that makes sense. If that doesn't make sense, then just cross multiply. So basically, we get this, in other words. Sine of theta is 8 over 9. Okay. Now, remember, so we want then a right triangle where this happens. You know, from here, we were able to get this, right? So we want a right triangle so that this happens. Okay, that's cool. Now, how do we do that? Well, we can set, we know sine of theta is opposite over hypotenuse, right? Well, if we set the opposite side equal to 8 and the hypotenuse equal to 9, right? Then sine of theta is 8 over 9. Remember, we only want a right triangle, okay, where this happens. And of course, there's more than one choice. But if we set the opposite to be 8 and the hypotenuse to be 9, you know, that'll work. Right? That'll work. Right? You can see from here, sine of theta is opposite over hypotenuse. Good. We got it. Now, we do have kind of a dilemma though, right? We don't know this side over here, the adjacent side. We don't know that side. Okay, can we obtain it? Can we figure it out? Well, yeah, Pythagorean theorem. Pythagorean's theorem. Okay, we can obtain it by Pythagorean's theorem. I called the side x instead of ADJ down here. I mean, I just did it for convenience, notational convenience. So from here, we get this. Okay. Then we can figure out x using Pythagorean's theorem. Okay. Now, so by Pythagorean's theorem, we have 8 squared plus x squared equals 9 squared. If you wrote down x squared plus 8 squared instead of 8 squared plus x squared, that's fine. You know, addition you can add in any order you want. So we get this here. And we can figure out what x is. We have 64, right? That's 8 squared, plus x squared is 81. Right? So 64 plus x squared is 81. That's what we have here. Okay, so that's good. We want to figure out x squared. Okay, so just like before, we subtract. We get x squared is 17. And so x is the square root of 17. So we know that x squared is 17, right? Well, then x is the square root of 17. That's what happens here. So that's what the adjacent side is. Okay? That's what we get here. Now, we have all three sides. We can get all the trig functions. I mean, we know what sine of theta is already. We know cosecant of theta already, right? You know, from cosecant, we got sine. So let's get the others. Cosine of theta is adjacent divided by hypotenuse. Adjacent over hypotenuse. So radical 17 over 9. So that's what we get here. Secant of theta, right? That's 1 over cosine. So what do? We flip this. We get 9 over radical 17. Tangent is opposite over adjacent. Okay? Opposite over adjacent. Right? 8 over radical 17. Cotangent is 1 over tangent. So in other words, 1 over tangent. You flip this. You get radical 17 over 8. So that's how the trig functions. Okay. All right, that's cool. Any questions on this one? Okay, well, let's move on then. So this is another kind of question that we should be able to work with, right? This is another. Okay. I was worried about the background noise, but I think it's okay. But this is another kind of question we should be able to work with, okay? Namely, we have a right triangle. If we know, we have the 90-degree angle, of course. If we know one of the other angles, that's what I'm calling theta. And if we know a side, one of the sides that is, we can get the other sides. I mean, I guess theoretically it's enough to just get one because then we have Pythagorean's theorem. But we can get the other two sides using trig. So that's what we're going to do here. So let's assume theta is 50 degrees. And let's also assume that A is 2. We're going to figure out what B is. And without using B, so without using Pythagorean's theorem, we can also get C. So we're going to use trig to get B and C. So let's do that. Okay, now. Okay, so how are we going to get B? Well, even before I get to the next slide, we should be able to see it. right? B, here, actually, you know what? Let me just do it. So, okay, let me just get rid of that. There we go, there we go, there we go. It was what I just took away was work I did for the other class, but I want to, you know, I'm going to do the work for you guys as well. So anyway, we know the angle, right? We want to know what B is. That's the opposite side. Okay? We also have the adjacent side, okay? You know, we have that. We have the opposite side, we have the adjacent side, okay? So what trig function are we going to use? Opposite, adjacent? Well, I know it's down here, but the opposite, but we have opposite, we have adjacent. Let's use tangent. So we're going to use tangent, okay? Let's use that.